functions. As we computed first and follow, here we have to compute lead and trail functions. Now, lead and trail are set of terminals or operators. See, lead is a list of all those terminal symbols which can appear first on any right-hand side of a production. See, right-hand side of a production is also called as body of a production. So, lead element is all the set of terminals that appear immediately after the first on the right side of a production. Now, how lead is to be calculated, there are certain rules for that. Similarly, trail is also called as last. Last is also a similar set of terminals which can appear on any right hand side of a production as the last element. You see, these are the bare definitions. Now we will look into the detailed rules of computing lead and trail. First, let us see how to compute lead. Here, I require you to write down these rules because when we apply these rules in the later portions of the class, it is handy to have these rules for ready reference. So please note down these rules. You can make the heading operator precedence grammar. Under that, you can have a subheading called as rules to compute lead. And please note down these two rules first. We have 4 rules altogether. So these 2 rules you please note down. Then I will start my explanation. Please note down and tell me once you have done. Nothing is compulsory. If anyone is writing, I will wait. Otherwise, I will advance. ആരെങ്കിലും എഴുതിയെടുക്കുന്നുണ്ടോ? കഴിഞ്ഞ ഒന്ന് പറയണേ. Otherwise, you cannot listen what I am telling. I hope you have completed rule number 1. What about rule number 2?
1 BTS.
Yes, please do rule number 2 also. I hope you have done.
Yes, sir.
See, rule number 1. If we have a production such as A derives Y A beta. If we have a production of this form, we know that A will be always a non-terminal. There is no worry on that. A is the head of the production and head of the production will be always a non-terminal. What about Y? Y is either a single non-terminal or epsilon. So Y, it can be there, it need not be there. Whereas Y is always a single non-terminal. So after Y, what will happen? Y, after Y, we get A. A represents an operator or terminal. So after beta, beta can be a group of strings after A. So if the derivation is A derives Y A beta, then in the list of lead of A, we can add A. That is the first rule. So lead of A will contain this operator because this operator is the first operator that appears after a single terminal. Suppose that this single terminal is not there. Suppose that we have, see, examples can be x plus 3. In x plus 3, when we write a programming expression, we know that x is a variable. Variable will be always non-terminals. So after x, we have plus. So plus becomes the lead element here. You can have also bracket and 3. It is also a while expression. When we say while 3, there bracket 3, then close bracket. There in front of first operator or terminal is bracket, left bracket itself. Even left bracket can be an element of lead. Why? Because y can be epsilon. So we will compute lead for a full grammar like this using all these available rules, then we will know. Now see this rule number 2. Whenever a portion, we suppose that we have a portion like A derives B, then what happens? Then lead A will consist of all the elements of lead B also. So these two rules are simple and direct, but I agree that these are very confusing. Rules for follow, rules for first, rules for top-down parsing, rules for bottom-up parsing, rules for predictive parsing, rules for shift-reduce parsing, now rules for operator process. We have no other way. We have to learn this, and somehow we have to clear our examinations and test papers. Somehow. So you please try to understand this, work out more examples, then things will be crystal clear for you. That's the only remedy. So now, when if we have a portion such as A derives B, then lead A will consist of lead B also. Add lead B to lead A. That means lead A equal to lead B. Now we will apply rules 1 and 2 for a given grammar. So the grammar given is E derives E plus T, E derives T, T derives T into F, T F, F derives an expression called as E, then F derives ID. So please note down this grammar also now, and name all these productions appropriately, because we have to use these, refer to these productions. Have you written this grammar?
Yes, sir.
Please tell me once you have done, because now we have to work. We can work this and write down. Don't write down now. This we will compute the values and note it down. So you can copy it down. You can copy on this part, the grammar part. Is it over?
Yes, sir.
Kutsia, directly look at the rules now. Don't think anything else. You read the rules. We are computing the rules, and rules we are computing something called as lead for a CFG. We are computing lead for a CFG. Just understand that. Now, what is lead? Suppose that you have a CFG like such as A derives Y A beta, where Y is a single non-terminal. Then in the lead of A will be then small a. Suppose that you have production called as A derives B. In such case, lead of A will be equal to lead of B. This is called as these are the two rules of computing lead. Now, with these two rules in our hand, let us compute now the lead element for these terminals, non-terminals. So we can see that, let us take F. See why we went for F. We can see that F and this F, it is directly we can apply these rules, where we have an operator in the beginning itself. So in such cases, directly we can compute. So it is an intuition. You can start with E and end up in F. There is no worry on that. So we are considering P5 now, and to P5, we'll see which of these rules can be applied. What is rule number 1? if A derives YA beta, where Y is a single non-terminal or Y is epsilon. So we see that there is an invisible Y here. Y is epsilon. What then what? Then after Y, there should be a. What is A? A is a terminal. So after the invisible Y, we can see that there is a left bracket here, which is a terminal. So lead of F will be A. A means left bracket. So I hope that we have applied rule number 1 on production P5 to compute lead of F. I hope it is clear. Clear? Then let us take
Yes, sir.
P6, production P6. In production P6, we will apply rule number 2. There, it is like A derives B. No, so when we derive, when we say this, we can say lead of F is also the set ID, because lead of ID will become ID itself. Hence, we have lead of F is the union of these two, left bracket and ID. That is how we can compute the lead of F making use of these two rules. I hope it is clear. So now we'll try to compute lead of T and lead of E. See here, the rules are here. You don't need to repeat this part. Please note down this. Consider P3 now. We are computing the lead for T. So consider P3. P3 can be computed. P3 can be seen, we can see P3 and take T derives T into F. Apply rule number 1. If A derives YA beta, where Y is a single non-terminal, T is a single non-terminal. So Y takes the position of T here. After Y we have A. After T we have star. So lead of T will be star. One element of lead of T is star. Applying rule number 1. Now let us take production number P3 and we'll apply rule 2 also here. P3. It is not P3, it is production number P4. We take P4 and apply rule number 2. Here is P4. P4 is T derives F. So lead of T, A derives B. So lead of A will contain lead of B also. Lead of T will contain lead of F. So lead of T is equal to lead of F. Lead of F we have calculated earlier. It is left bracket and ID. So let us take a union of these two. So entire lead of T will become star less than an ID. I hope it is clear. And I hope you have noted it down also. I'm ready to wait till you have noted down. Please note it down. Over. You have written this part.
Yes, sir.
This is written. What about the second thing, lead T? This is written, also written. This part is over.
Yes, sir.
So I hope that you know now how to calculate lead of T in these two steps from these two productions. Now let us see how to calculate lead of E. So again, we'll take up P1 and apply rule 1. A derives YA beta, Y and E, A and plus. So lead of A becomes lead this plus. We'll take P2 and apply rule 2. So A derives B, E derives T, lead of E becomes lead of T. So we'll take a union of these and we have that. So now we have computed the lead elements of all non-terminals using these two rules. So I hope that the rules are clear and how to compute them using these rules. Both are clear for at least for this grammar. Please